Hi everyone, welcome back to Array Blog once again. So, in the last video, we learned about indexing and slicing in array, and in this video, we are going to explore array operation in NumPy, including arithmetic operation, vectorize operation, broadcasting, and universal function. So, what we'll do, we'll create a file first that will say array operation.py, right? What we'll do, we'll import the NumPy array first np, right? And now we are going to perform some arithmetic operator. So first we'll create array1 equals to np dot array, and then we'll write some variable that is 10, 20, and 30, and then 40, right? Now what we'll do, we'll create the second one, array2 equals to, say, np dot array, and then we'll say 1, 2, 3, and then 4, right? Now what you're going to do, we are going to perform some arithmetic operation, that is addition, subtraction, multiplication, and division. So I'll write all these and then I'll explain. So we'll say addition, and then we can say arr1 plus array2, right? And what we're going to do, we are going to just copy this, right? Addition, subtraction, division, and multiplication, right? Now, so in NumPy, you can perform element-wise arithmetic operation directly on arrays. So all these operations are called vectorize, meaning they operate on entire array at once without a loop, right? So what we'll do, we'll run this first. Python array see. So in addition, 10 plus 1, we got 11, 2 plus 20, that is 22, and 30 plus 3, 33. And in a subtraction, we got subtraction. We have written everywhere addition, that is subtraction, and we'll say multiplication, and no, we have it's a division. No, it's a multiplication, and then this one is division, right? So let's run it again and we'll see. So we got the division and we got the multiplication, right? So that's how like arithmetic operation work in a NumPy array, and also these are the vectorized operation, right? Meaning they operate on an entire array at once without using loops. Now we'll see some vectorized operation, vectorized operation versus loop, right? So what we'll do, we'll import time first. We'll say import time, right? And we'll create a list. 1 equals to 1, 2, 3, 4, 4, and then 5, right? 5. For list 2, we are say 5, 4, 3, 2, and then 1, right? Now we are going to say start equals to time, right? And we'll get a result equals to x plus y for x comma y, x and x plus y for x, and y in zip, that is list 1 comma list 2, right? And then end equals to that is time dot time, And what we'll say print, let's say Python list time, and we'll say end minus start, right? So here time give you current time in a second, and we store this in a start, right? We are going to store this in a start, and then this one, the x plus y for x, and comma y in zip list and list 2 list comparison, that's add element of list 1 and list 2 one by one, and then x plus y is basically is calculated for each pair, and end time dot time record the record the time after the operation is completed. So let's run it and we'll see what happened. So see where here you go. So we get the Python list time, that is 2.384 end minus start, right? And it say the record the time after the operation is completed. So we get the start time and we get the end time, and in the end we get the uh, Python list time, right? Now we get the Python list time, that is NumPy uses a vectorize operation which are much faster than Python loop. This is because Python operation perform at a C level language, right? So and how we can see that the Python list NumPy array list are fast. So what we'll do, we'll write another code that say arr1 equals to np dot array, and we'll convert that list into list 1, and we'll say array2 equals to np dot array, and we'll say list 2, right? Will be converted into the NumPy array. Now we'll say start equals to time dot time, or we can say start 1. Let's just say start 1, that is the start time, and we'll say result, we are going to say equals to, that is time dot time, right? And we'll get the end equals to time, no, we have to get the result, that is array 1 plus array 2. Okay, so let me, result equals to arr1 plus arr2, and this is going to be end, right? And we'll print the time. So print, that is NumPy array time, right? We'll say end minus start. So this is the, here we are going to get the two list addition, right? This is how much time it is going to take for doing the addition, and this is for the NumPy array. So we'll run this. See, for the Python list we get the 3.377, and for the NumPy array we get the 2.31266, right? So NumPy uses vectorize operation which are much faster than loops, and this is because NumPy perform operation at the C level language, right? Making it highly efficient for large data set. Now, so we'll comment this. So we'll comment this part, and now we are going to use the broadcasting, right? So what we'll do, we'll declare array equals to np dot array, and we'll say 1, 2, and 3, right? And we declare a scalar equals to 10, right? So broadcasting allow us to perform operation on array of a different shapes, right? That's how, like that is what broadcasting. And what we are going to do, we'll say print array plus scalar, and then array plus scalar, ca, yeah, yeah, right. So we'll run this, clear this and run this. See, we got 11, 12 and 30, right? So broadcasting allow us NumPy. So broadcasting allows NumPy to perform operation on different array of different shapes basically. So we are adding this, right? You can also add a 2D 1D array to 2D array, right? So this make array operation extremely flexible and concise. So there is another one that is called universal function, right? Now what we're going to do, we have declared or we can declare array1 equals to np dot array, and we'll say 1, 4, 9 and then 16, right? So we can get the square root. So we'll say print square root. We can say np dot sqrt, and we'll pass array, right? We can also get exponential. We'll type this first, then exponential. I'll write exponential and then np dot exp, and we'll pass the array. And array is going to be array 1 and array 1. So let's run it and see. So we got the exponential of this, and we got the square root of this. 1 is square root 1, 4 is square root 2, and 9 is square root of 3, and 16 is square root of for 16 it is going to be 4, right? So you can also use u function for the addition, right? And you can use the sin for the sign, right? So NumPy provide a universal function that perform element wise operation efficiently. Some common u function are basically a square root, that where we use this exponential, sine, and addition. These function are optimized and much faster than Python loops. So you can also combine multiple operation in a single line using a vectorized operation and using this function, right? So NumPy handle all the computation efficiently behind the scene. So in this video, we perform arithmetic operation. We learn about vectorized operation versus loop. So that we did it here, and we see the how much time it takes to learn a list and run a Python list and a NumPy array list. And we explore broadcasting, how we can work with a different kind of shapes, array of different shapes, and we use universal function, that is a np.add, np.square root, and np.exponential. So in the next video, we are going to cover array manipulation, that is reshaping, stacking, and splitting and copying arrays. So if you found this video helpful, don't forget to like, share, and subscribe. So see you into the next one. Thank you.